So today we will be looking at Ohm's Law. It's a crucial theory in electrical engineering and just circuit analysis in general. So to begin with Ohm's Law, we have V, which is equal to I times R. So V stands for the voltage. This could be the potential difference across a circuit. Usually it's just a battery. Then we have I, which is the flow of current, which will be explained later. And then we have R, which is the resistance in a circuit, also be explained later. So a good way of looking at this theory is to observe I, which is the flow of electrons. So let me rearrange the equation. We have I, which equals voltage over R. This basically says that current is proportional to V, and current is going to be proportional to 1 over R. So if current increases, so if the flow of electrons increases, voltage will increase. If the flow of this increases, that of current increases, that means the resistance has decreased. So if we increase this, then this will decrease. Now, a good analogy to help explain the flow of electrons is to observe, let's say, something that flows in real life. Let's say a stream or a river, just a body of water that flows. So these squiggly lines represent water, or in this case, the flow of electrons. So let's label it electron. And then, so this will represent I. So see, these electrons are flowing just in a direction. So that means that the total, or the potential difference across this flow of electrons will be equal to the voltage of the circuit. Now, we want to look at resistance. So anything that obstructs the flow of electrons, let's say we put a rock right here and like through a little bit of this, so only marginal amount will flow through and nothing will flow through there, then the flow is obstructed, it is decreased. Therefore, the voltage will also decrease. So these rocks represent an obstruction to the flow of electrons. Now, to bring this back into terms of circuit analysis, let's just draw out, let's say, we have a battery here, plus minus. So this will be equal to V. Then we have wires that connect this battery to a resistor. So electrons will flow this way in a counterclockwise motion. So this is I. This resistor will obviously have a resistance of R. So if we were looking at this circuit and just wanted to solve for, let's say, the voltage, since there's only one component, the voltage will be equal to I times R, be equal to this flow through the resistor. Because when it comes back around, obviously the resistor will resist the current, which will decrease the voltage. So by looking through the circuit, we just solve this equation, and then we get whatever we want. So Ohm's Law is really crucial for helping solve circuits that are much more dense and have a lot more components. Let's say we have a battery here, we have a resistor here, we have a resistor here, we have like a resistor here. Everything flows back. By using Ohm's Law, we can analyze this circuit and easily solve for, let's say, the voltage across the battery if we didn't know that. Or we could solve for the current that flows through different parts of the circuit. And with Ohm's Law, we can easily solve this circuit for whatever we want, given that we know certain parts about it. And it is crucial for help understanding electrical engineering, and it is crucial for solving DC circuits.